Okay, I'll give a really quick summary about processes, threads, synchronous, asynchronous, multi-threading, single threading, and concurrency and parallelism. Okay, we have processes. Okay, what are these processes? These are our applications, whatever we have to run and process. Okay, inside of each process, we can have multiple threads. Okay, threads one, thread two, thread three. Now, now let's imagine this thread actually has multiple tasks, or let's say a block of code, or I'll call it block one, block two. Okay, block one, block two, block three. Okay, right. So this can rather one thread can just be talking about a single main function call. Uh, Main function call can just call and do a thing. So let's take there are three functions being called for simple example. One of this function is calling our database connectivity. One is calling an API, and one is doing some processing. Right? I'm talking about a single thread. Now we just have one CPU core with us. Okay. Now the thing with a core is a core can only execute one thread or work with a single thread at an instance. At an instance to be emphasized. So now our one core will come. Okay, we have multiple blocks over here. In we are just talking about in within a single thread. Okay, we are talking about a single thread. Let's just zoom in into there and let's work with that. Okay, we have a process, we have a single thread, and we have one CPU core with us. We have to execute thread one. One way of doing it is okay. I have to do this. I'll do this one. Okay, then this one, then this one. Right. Let's say if there is a wait in between these two of 2 milliseconds, we are gonna wait for that 2 millisecond. We are gonna wait for this for the next thing to begin. With this 2 millisecond, we are just sitting around. Like let's say we are calling an API at block one and we are waiting for the response. We are just sitting idle and just waiting for the response for the time being. This is a synchronous programming method. So I'll write it over here. Synchronous sync way. We're talking about sync right now. Sync we can happen on a single thread. We'll start working on this thread. We will take this block one, then we'll do block two, and then we'll block three, and then we'll complete this thread. This is synchronous. Now, if I want to do asynchronous, in asynchronous, our CPU core will come, will take block one, and it says, okay, I have to wait for back some other API to call. Within that time, we are doing nothing because that API call is done and we are waiting for the response. That response is not calculated by us, it's calculated by the other API, and we are doing idle work. Let's just do one thing, let's start executing the block two. The block one is not completed yet. We are doing block two now, or block three. We are waiting, then block two is completed. Now we can either go back to block one, most probably, or we can do three, and then we can keep switching between until all three of them are done. This is called asynchronous way of coding. Okay. One thing to be noted, sync and async both happen within a function, within a thread, sorry. Sync and async happen within a single thread. Okay. Happen within a single thread. Okay, now I'll just make it small and keep it on the side for us to keep in mind that I have talked about this point. Now, second thing, which is multi-threading. Multi-threading, we still, once again, I'm talking about multi-threading now. Okay, multi-threading. We put this on the side, now we're talking about multi-threading. It is maximums, we are talking about that. Okay, multi-threading is like, okay, CPU core go and start working on thread one. Okay, I don't know what is happening inside thread one. It could be done synchronously, async. I don't care. I do not care. We are doing thread one now. We are passing through it. Okay, something happened. We are waiting for that to happen and be completed. We will be like, okay, I'll go to thread two. I'll start working on thread two now because there is some waiting happening over there. It's better to do this thing because we have nothing to do over there now. In thread one, there is some wait. There is something happening in between, which is saying us to wait for the bit, and we have nothing else to do after that. And like it has been not been programmed to us to go and do other things or some other random thing happening which just needs some time. We'll start working on thread two. Now, this thread switching is done by our operating system. Okay, but when we're doing asynchronously and we're jumping between these are done more of by us or by our programming language or by us coding and those things in there. Within a thread, toggle and switching is done by us or by the program or the language you're coding in. But within thread, switching is scheduled and maintained mainly by your operating system. Okay, that's one thing. Multi-threading, we are toggling and switching between threads to complete all of them. Right. So far, so forth, we have been only having one single core. So single core will be like, okay, I'll start working on this. We have some problem. We'll wait. We'll do thread two. Thread two, we are completed. We'll either go back to thread one, complete that, and thread three, or whatever the operating system decides has to be done. It's in the hands of operating system. We don't really touch much with that, but yeah, OSs are good. Now we'll talk about multi-threading plus our parallelism. I don't know the spelling of parallelism, but sorry. In parallelism, we have multiple cores. Okay, CPU core one, we can have a CPU core two, and a CPU core three. Okay, CPU core one will take care of thread one, CPU core two will take care of thread two, CPU three will take off three core three. And yeah, usually our computers usually are 8 cores, 4 cores, or even 16 cores core CPUs. So it is quite a common thing to happen nowadays. Yeah, and then there is also can be something like that if you don't, we have only two threads. So this will, core one will take care of core thread one, and will this thing will take care of thread two. And if we have some waiting in there, it will go and start working on thread three. While this thing is happening, we can come over here to come over here, complete this, and come back over here. So there can be multi-threading even between them as well. And while doing parallelism, we can have multi-threading. So that's parallelism. Yeah, matlab, meaning multiple cores are executing different threads at an instance. And at the same time, a thread can go and start working on different, so one core can go and do some other thread, which makes it multi-threading and parallelism at the same time, which is how usually our operating systems are working nowadays. So yeah, crazy fast. No, yeah, that's sort of it.